Just like how it's still on the wall. But I'm trying to watch them now. I tried watching it a few times, but I haven't got this.
All right, guys, any questions from that test? I tell you, my other two classes, I have really no problem with this as long as people can hear me and as long as you eventually shut up. But my other two classes are like totally, they scare me. I come in, they're dead. And then I come over and I'm like, all right, everybody settle down. You know, and they're like, what? You guys scare me. So this is good. This is normal. Just make sure everybody can hear me. Yeah, you did. Are there any questions from the test? Yeah.
I still, for some reason, I guess, struggle with why two negatives plus each other is not a negative.
Oh, it is a negative. Two negatives plus each other? Yeah.
You subtract them and put a negative, right?
Oh, I see what happened. If I have this situation here, guys. Are those two negatives? All right, let me try again. Guys.
Hey guys, come on.
Are those two negatives? There's the negative 17 and there's the negative 4. Cool. Are they adding together? Should this get more negative? Are they adding together? What operation is between them?
Subtraction.
Yeah. Now you don't have to get that deep into it. We all know what minus a negative becomes. What does minus a negative become? Because those two negatives do what? Cancel each other out. So if I did this, what did I do wrong?
You didn't cancel it.
That minus can't suddenly by itself decide to become positive, right? It's these two negatives together that become positive.
Right.
Now, do I have two negatives that are combining? No. I have a negative 17 and I'm adding 4 to it. So should it get more negative or should it go towards the positive side more?
Positive.
Yeah. So if I have negative 17 plus 4, they're different signs. What do? Subtract 13 and you put
Negative.
the negative one. I love it. Okay, cool.
That's what I did on letter E. I don't know.
Oh, what would the bigger one be? The bigger one would have what sign?
Oh, I see.
Okay,
Be
cool.
positive.
Like negative 11 is negative 30. We're not positive. Negatives in between.
So if you have, like negative 9 minus 7.
No, yeah.
I'm not going to do anybody's work. Right? What's different about this one? There's not another negative somewhere to kill somebody, right? So they're going to stay negative. They're both negative. What do I do when they're the same sign? Add them up, and then put the sign back on, right? So 9 and 7 makes 16, and since they're both negative, it's going to be negative 16. So I really want us to get over I know that teachers hammer this in your heads, but you have to differentiate. Two negatives make a positive when you are multiplying. And when I'm adding, when I'm combining things, when I'm putting them together like this, I like to think of it as money. I can't make my debt disappear by putting it with more debt. I owe $9 here, and then let me put them together, bam, positive 16. No, can't do that. Money appears in my pocket. Boop. So here, this will be negative 9 minus 7. They're the same sign. You add them, and then you put the sign back on. Right, they're the same sign, so they do combine together. They actually, none of them are competing against the other one. They're both going in the same direction. Negative 9, down 7. So it ends up even more negative, yeah.
Why just for the rounding? The 10,000 rounding? I didn't understand.
Oh, if I had this number 827,492, and I said round to the nearest 10 thousandths. What number is in the 10,000th place?
Two.
The 2.
Uh-huh.
Now, what do I look at to tell me what to do with that 2?
To the 7.
Look through the 7. So what should that 2 do?
3.
Good. Now what's wrong if I write this?
No, 8.
8.
Oh yeah, exactly. Okay. So I saw a few of this. And you gotta be careful, you're trying to tell me that 827,492 is approximately 30,000. Like, whoa, that's a bit, that's a big step. You gotta keep the other numbers there, right? That 27,492, is it closer to 30,000 or is it closer to 20,000? It's closer to 30,000. So you make it 830,000. Boop, like that. You can't just eliminate the other numbers because now you've got an entirely different number. You can't claim that they're approximately the same. That's what rounding does. That's about this. And we round because we like whole numbers a lot better than we like specific numbers like that. Does that really get to your question or no? Do you remember who asked the question? Yeah.
No, this one.
Oh,
Another one.
okay.
X plus 1 equal.
Is it from the test?
Yeah.
So what was yours?
X plus 1 equal X.
Oh yeah, oh. Alright, so, and let me say this real quick, just make sure everybody understands. You can make corrections to this just like a quiz. The bonus, you only get one shot. So if you want to correct the bonus, great, but it's just for fun. So I can certainly tell you about the bonus. There was one bonus problem, it was basically something like this for everybody. X plus something equals X. And there's a couple things going on here that we're going to get into a lot deeper today, because we're going to get into a little bit more advanced equations, trying to solve it. Not crazy equations, just a little bit more stuff going on. What is my goal in solving any equation? What's the goal? What do I want the form to be? I want, say again. X equals something, right? Now what does that imply then? If I have any numbers that are on both sides, I want to make them only on one side. I want to kill them on this side, and whatever I do to that side to kill it, I have to do the other side. So they end up kind of going to that other side. The same thing with the x's, right? If I have x's on both sides, I want to kill them on one side so they all go to the other side. I want x's on one side, numbers on the other side. You guys semi with me? Not really? All right. So before I do this one, let's do an example. Let me pull up here actually. Let's do one that's not too freaky, because that's freaky. And that's why I made it bonus. You can do anything I want to in bonus. So are my numbers all on one side? Now careful, which ones of these are x's and which one of these are numbers? Yeah, here's my numbers, right?
Yeah.
Now I know 2 and 3 are numbers, but they are 2 x's and 3 x's. That's what they really mean. So what are my x's? These are my x's. What are my numbers? -7. So let me ask again. Are all my numbers together on one side?
Yes.
Yes. Are all my x's together on one side? No. Do you guys sense how to approach any equation? We're going to start throwing more stuff into the equations to simplify and put stuff together. But the end is going to be, get my x's on one side, get my numbers on the other side. Because then you guarantee yourself to end up here. X equals something, and then I know what it is. It's not a mystery anymore now. I know X, what the hell it is. So what can I do here? What's the problem? The problem is my x's aren't together. Where are the x's currently that I don't want them to be there? Again, what do I want? Numbers on one side, x's on the other side. So which x's are in the wrong place? 2x. Because they're bugging the freaking -7, right?
Yeah.
He wants to be by himself.
Yeah.
So how do I kill that 2x? How do I cancel it out?
Subtract 2x.
Exactly. Cool. Subtract. I love it. Can't divide it. If you divided it, you have to divide everything. That would so suck. You have x's on the bottom, that's freaky stuff. Right? Subtract it, what happens here? 2x minus 2x, that's exactly what I want it to do. I want it gone. So the whole idea of solving equations is make certain things disappear. Whatever you do on one side, you have to do to the other side, so they end up kind of moving.
So when you cross that out, does the x's still stay there, or they?
No, what is 2x's minus 2x's? Nothing. If I have 2 apples sitting here, somebody comes along and takes my 2 apples. 2 apples minus 2 apples is no food for me.
So the x's, they go with the 2's.
Now be careful, there's no 2, there's no x. There are 2 x's here.
Okay.
And what did we just do? We subtracted 2 x's. Any x's left?
There's nothing.
Nothing, there's nothing left there. And what's over here? There were 3 x's. If I take 2x away, there's 1 x. I love it. Are we cool with that?
Yeah.
Now that's something we're going to focus on even more today, is the idea of like terms. I don't want to see anybody do 2x minus 7 and come out with negative 5x. That can't be done. These cannot be put together because they're not like terms. One is counting how many x's I got, and the other one is just a number. I can't put those together. So 3x minus 2x is 1x. I love it. So in this case, x is negative 7. I'm done.
You sure? We can say directly 3x minus 2x.
Sure, sure. You can write this a few different ways. I mean, this is done. I recommend this. I recommend that because some of my colleagues really force their students to do this, and I personally don't really like doing this because then it's really easy to not see what the hell you did. You see that? They tell them to put it in line, to put it on the same line. I like this much better because then I can see what I just did. Now, if you personally like this better, do it. Cool. I love it. If it makes sense. For me, I don't like that myself. Because when I come back to look at my work, I'm like, what was there? What did I do? Here, I know exactly what I did. How you guys doing so far?
Why do you subtract?
Say again? Sir?
I'm sorry, but I don't understand that.
X.
Oh, like, I'm not done with that one
Okay, never
yet.
mind. I'll just go to the tutor center.
Oh, go ahead.
No,
What's
no,
up?
no, it's fine.
Yeah, I'll ask it, because I
Yes.
think I have the same question. If you have like 2x plus 7 equals 3x, will you just add 2x on each side then? Is that what you're asking?
Okay, cool. And you guys
How do
don't.
you know when to minus and subtract? Is it just
You can ask any question you want to. If there's anybody around you giving any shit about not understanding something, that's their problem. You ask whatever you want to. I don't care about any whatever's going out there. Yeah, major issues with somebody else, let me know. That's a harassment issue, but if they're just rolling their eyes or whatever, let them do whatever they want to. I don't care. So this is a slightly different problem, right? To tell you honestly, this is not different at all. This is still x's, numbers, x's. I still want to get my x's together. Now, if I add 2x, will that do what I want it to? And again, what do I want to have happen to these things? I want them to go away. So if I add 2x to both sides, what is 2x plus 2x? Yeah, it doesn't do what I want it to. Do you guys see? So why did I subtract 2x? Because I wanted them to go away. Now, a better question, not a better question, but one that would lead to what you thought should happen. So this would still be minus 2x. And those would still cancel. The 7 is there, and this is x.
What if you got numbers on both sides?
Just a second. That's today's lecture. What to do when you get more stuff on both sides. Hold on. So if I had this, now we're talking, right? Now how do you kill the thing you don't want? I don't want the stupid negative 2x there, do I? So I have to add so that they will actually cancel. So everything you do in an equation, you have to stop and ask yourself, did that just do what I really wanted it to do? Because always on equations I see, I don't care what level of math I teach, I see somebody have 8 plus 8 is gone. I'm like, and I circle, how did that happen? Right? Because your brain kind of outpaces yourself and like, yeah, that's what I want to have happen, it's going to happen. Yeah?
I was gonna ask, so is the reason that you decided to do minus 2x and not 3x is because the 2x is a part of the equation?
Oh, so that's a good question.
Or do you?
Oh, don't worry, I'll come back to this. So let me look at this one more time. If I subtracted 3x, I'm overloading one side. Do you see what I mean when I say that? One side is currently overloaded. Which side would you say is overloaded with stuff? This side. It's got x's and numbers. So if I subtract 3x, now I get this a lot. And what I get is this. I get somebody put down here negative x equals negative 7. Now take a second. Can you see why they would put that, but can you see where they went wrong? And this is huge. This is actually, especially for those of us who are messy like me, this is why I do equations like I do, because I know I'm freaking messy. Right? If I'm not careful, I'll lose parts of it. But this person was not careful. Where's that negative 7? Which side of the equation is it on? Now, how did it just sneak over there? So if you really are careful, so this is no good. 2x minus 3x is negative x. Is that cool? 2 minus 3, negative 1.
Yeah.
The negative 7 is still here. What's on that side?
Nothing.
Now technically it's fine as long as you, now what do I want to have go over there? I can add the x over there.
Yeah, that's more easier than that.
I agree. There's one less step. Is that cool?
Yeah.
As long as you don't do that. This is okay as long as you go ahead and add the x, you're fine. You didn't have to do this though. Kind of like added one step away. But I desperately want you guys, we're going to start, adding stuff into both sides. We have to do a little simplification first or whatever. But you always approach a part of the problem where you have this. What side do you want to put your x's on? Put your numbers on the other side.
Is it another way that could have been done?
Which one?
That what you just not done over here on the number 2 over here.
Here?
On the right hand side.
Over there. Oh.
Is it another way like that you took the 2x and the 3x and put them together without doing them like you did them like this, and put them like the 2x over here with the 3x like you did do, but you got a negative sign there.
Oh yeah, okay. Well, I mean, you could do this. I don't know if this is
Put all
what you
the
mean.
x's together. What I'm saying.
Like that?
All the x's together, and then adding or subtracting what it is.
You
And that's how
can't put the x's together the way they are because where are they? They're on opposite sides.
opposite side, but it just seemed like that's what it was done, but you put a negative in front of it.
Definitely.
It's still got an x, a negative
Exactly.
x over there.
Exactly. And I mean, the whole reason is that equal sign definitely chops it into two sides. Cool? And somebody can't just suddenly go to the other side because it wouldn't be balanced then. So for example, if I have 5 plus 1 is 6, and that's true, right? I can't suddenly have the 1 just kind of show up over there because now that's not true.
You could take it away.
Exactly. If I actually did this work that I have to do, maybe I don't want the 1 there. Let me subtract the 1. Now 5 equals 5. That's true. So that's really what's going on in the background. The reason this is difficult is because there's a freaking x in there. We don't know what the hell that number is. So it is going to be more difficult because I'm working with something I don't even know what the hell it is. This, though, is exactly the same idea. You've got to do the same thing to both sides to maintain the equality and make sure that it still is truly equal to each other. Exactly for this reason right there. Yeah.
On that problem right there, why didn't you subtract 2x
Yes,
from both sides
that's
instead?
definitely what we should do, like we did with the one I just erased here.
Okay.
This was because of a question about what would happen if I subtracted 3x instead, and then I would get overloaded.
Okay.
Right? So this is still works, but not the best way to do this. I like that. So this is a
So you could potentially have a negative x.
bad example here. On purpose, a bad example. You with me?
So you're saying that we could potentially have a negative x.
Of course, sure.
Okay.
Yeah, go ahead. Don't worry, we'll get into that today. We're going to look at a little more advanced stuff today.
I understand all that you just showed.
Sweet, my favorite.
But that
percent.
first example that she asked, how can you have a number,
All right.
add something to it,
All right.
and get anything?
So remember, what was this problem? Where was it on the test?
Bonus.
Bonus. That should warn you, right?
Yeah.
That's something freaky. Now, on one level, I love it. I think you were the one that actually came up and said this to me. If you take a step outside of that, just step back. Don't get so stuck in the 8 and the X's, you know. Just look at what this says. What number, when I add 8 to it, is the same as what it was? Yeah, so you know the answer should somehow come out to be bogus. That's the only way math can tell me, dude, there's something wrong, is for it to tell me 0 equals 8 or something, right? And that's exactly what's going to happen here. How do I, approaching it like we just did these, what's not where it should be? That X with the 8, right? So I subtract X from both sides. And this is where I have students, it's kind of funny, they try to save the X. They're like paramedics. Come on, X. Come on. Clear. Those X's are dead. Let them go, right? 0. But then you have to write the 0 because 8 equals 0. And this is what people are trying to avoid, and I don't blame you, because you're like, shit, I can't tell the teacher 8 equals 0. But this isn't you claiming this. This is math saying, dude, if this equation's okay, then 8 can equal 0. So what is math really saying then? Can 8 equal 0? Therefore, this equation is good. Not okay. It's got, what's the solution? No solution. That's what I need to see on this guy. So some guy said undefined. Some guys said, I like it. One guy said not good. Yeah, I like that. Not good. I didn't really know what you meant. Like, I don't know what to do with this, or was the equation bad? I don't know.
Said it wasn't no good.
So I always need, the question is solved. So your answer must always be the solution.
Okay.
So if there is no solution, that's your answer, no solution.
I
Yeah.
couldn't think of the solution. I said, no good.
No.
But
No.
the answer like 8 equals 0 is solution.
Yes, no solution. Now, technically, and I'm not going to get into the details, infinity plus 8 is still infinity, so, but infinity is not an answer. Infinity is not a number. Infinity is a process. Cool? If infinity is a number, then what's infinity plus 1? Wait, so infinity is a process. Infinity is like start at 1, add 1, do that for the rest of eternity. That's infinity. It never gets somewhere, right? Like nirvana. You can never reach it. If you do, let me know. Any other questions for you, Justin? Where did I lose that? Yeah.
Can you do one like number 2 from the bonus?
Oh, now I made this bonus and I told you I wasn't going to give you one this long in a regular problem, but I really want you guys to not be bothered by this. If you're able to do the smaller order operations problems, this is just a little longer, so it doesn't change anything about how you approach it. What do you do first? Parentheses, order operations, please, right? So everything else stays exactly the way it is. What's 3 minus 5?
2.
I like it. Real quick, what are the very last things I'm going to do? What's at the end of the order operation? Yeah, subtraction. For some reason, I still have a lot of people, I think it's just human to think that the division breaks it up into 2 sides.
5 minus 2.
It doesn't, right? What's the only thing I'm dividing by? 10. And what am I dividing 10 by? This. Not, this is not involved, that's not involved. Okay. What's the next thing I do?
Minus exponent.
Yeah, the exponent, good.
Yeah.
8 minus 5 times, what's negative 2 squared?
4.
Negative, negative makes positive 4, I love it.
4.
That's a 4. I know, man. And then what's the next thing I do?
5 times 4.
5 times 4, good.
Yeah.
8
Minus.
minus 20.
Good.
And then,
Minus
sorry.
12.
Yeah. Good, division. So 20 divided by 10? 2. And now just 8 minus 2 is?
6.
Minus 2 is? 4. Hopefully it's not. Okay, sure. Is that any questions on that? Is that all right? But you see, I mean, the reason people mess up on this problem is you guys keep the whole thing in your brain. I think part of you feels like you're supposed to be able to do the whole thing.
No, I just didn't. I subtracted instead of added.
Okay.
My bad.
I'm not used to writing it all out.
I think I went too fast.
I had a request.
My problem was I added for minus 5. And then when I went before, so I was doing 2 times 2.
Now I was nicer on this problem than I really wanted to be, because I noticed when I gave you these, but I put them out of order, like if I put a C there, a lot of people just put the value of A in. Wherever A is should go with 3, wherever it is. Right?
Yes.
Okay. That's about half you guys paying attention, that's all right. So what do I do then? How do I start this off?
Like a
4
number.
times
Yeah.
3.
4
Push the
times
value
3,
of the variable.
because A is 3, plus 2 times
Minus 5.
C is 2,
Oh, yeah.
and D,
Negative
5. And now you just attack it with order operations. The last thing I'm going to do there is add. This isn't really subtraction, this is part of the multiplication, yeah. Cool. So 4 times 3, plus, and what's 2 times 2 times negative 5? Let's see, 2 times 2 is?
It'll be negative.
Times negative 5?
Negative 20.
Beautiful. And then 12 plus negative 20, how far down do you end up?
8.
8 in the hole, right? You're 8 in the hole.
Negative 8.
Negative 8. Is that cool? Because again, they're opposite signs. 20 minus 12 is 8. The bigger one's negative. Bam. So, I mean, when I write this, and I say A is 3, this does not mean it's 43. What operation does this tell me? Multiplication, yeah. So be careful. I saw a few people doing that. That A is not just taking the place of the ones place. No, it means multiply when they're sitting next to each other. Cool. Okay. And yeah.
I was going to ask about one of the other bonus questions, where you have the 3x plus 4 equals 5x minus 18. Like, how far do you go? And
We'll get into that today. I'll just hold off on that, because that's going to be today's lecture. So I just put that on there to see who already kind of knew how to attack, one that was a little more advanced. Yeah.
I'm not going to repeat.
Don't worry, that's today's lecture. So next test, it'll be not a bonus.
Oh.
Yeah.
I don't like that.
All right.
No way.
So I keep talking about what we're going to talk about, so let's talk about it. Chapter 3. So let's first start with something that is what makes people have the most trouble in Math 90, Math 103, Math 110, is like terms. I mean, they all still hate word problems, they all still don't like graphing, they all don't like other stuff. But what actually makes it difficult for them to do anything is understanding how like terms work. So what the hell is like terms? What does that mean? It should be terms that are somehow alike. That makes sense? So let me just start off like this. What does 5x mean? I'm going to get not what I want the first answer. What does 5x mean?
It means that 5 is being multiplied by a number?
Yeah, 5 times x. Now go further. What does that really mean? I have 5 x's doing what? Not multiplying. That would be x to the 5th power. That'd be an x power. This will be 5 x's adding.
Oh, yeah.
All right. So let's stop right there for a second. So again, this is sort of like all of math is just figuring out the shorthand. So I don't want to write 20x is x plus x plus x plus x. I don't want to write that. I'd much rather write 20x. And then just let everybody know, hey, that means you added x 20 times. And everybody's like, oh, cool, that's fine. So I don't waste time. You with me? Same idea as exponents, except exponents keep track of how many things I'm multiplying. So if I had 25s multiplying, I could write 5 to the 20th power. Much nicer, less work. Cool. So the thing about that, if you really focus on this, it's a chain of 5x's. So if I have a chain of 5x's, and I add on to the end 2 more x's, how big is my chain of x's now? 7x.
7.
Let me just stop right there. You guys semi with me here. I mean, that's all there is to it. If you just have in your brain this image, don't, please dear God, if I put 11x, don't write x plus x plus x plus x. Seriously, don't. You need to get away from doing that. Think about it in your head though, you got 5 x's in a row. If I add on 2 more x's on the end, of course now I have 7 x's in a row. So it is just 5 plus 2, 7. And it's keeping track of how many x's I have.
So
Right?
like terms is added.
Now what's wrong with this then? Or not wrong, but what can I do with this?
Now you have y.
Nothing.
Good. The correct answer is I can't do crap with that.
If you say 5x.
Or whatever expletive you use. So I can't do anything. This is a chain of x's and a chain of y's. I can't say I have 7 what? I don't have 7 anything. I have 5 x's and 2 y's. You guys with me? So that's the difference. That's what like terms is. This is like because it's the same variables to the same power. So what do I mean by that? Well, we're not going to quite get into this too much, but let me just give you one example. If I have 7x squared minus 3x squared, what is that?
4x.
4x squared.
Yeah, don't
X plus
overthink
4x.
it. Don't overthink it. 7 of something minus 3 of something is 4 of that thing, isn't it?
Yep.
So the mistake I always get is something like this. And what I would say is, I don't have any freaking x to the 4th. How do you end up with 4 of them? I have 7 of something. I take 3 of those things away. I end up with 4 of those things. Cool. I want to make that point really big right now, because that's what throws people off also in algebra. When you combine things with powers, you don't combine the powers. You're just keeping track of how many of those things you've got. Yes?
Then when do you add the exponent?
When you multiply.
Oh.
Because what are exponents based on? What operation? Multiplication. See, that's when exponents start to change, is when you start playing with their operation. They're based on multiplication. They're going to wait for that to happen. So what about this here, guys? Let me. This is a little bit more than I want to do. That's all right. Let me just throw that at you and see what you think. So we're going to vote for nothing.
10x squared.
How many x squares do you see up there?
1.
No, come on now. How many x squares do you see up there? I see 7 of them. I'm with you. I understand. But we got to think about that. In your head, what would that chain look like? 7 of these in a row adding, right?
Yep.
So the answer can't be, and I'm not picking on you, because I understand where it comes from. The answer can't be 10x squared, because I already know I've only got 7 of them up there. So do I have any more x squares for this thing?
Yeah, because you got the 2 to the second power, right?
So right here, do I have any more x squares in here anywhere for this guy to go with? Do I have any more x's for this guy to go with?
No.
Do I have any like terms?
No.
So that's what I mean right here, to the same power.
Okay, so
Right?
you wouldn't mess with the 2.
X squared is not like terms with x. Because what would the answer be? 10 what? They're not the same thing, so I can't consolidate it. You with me? Math can only do so much as far as paring things down. It says, all right, this is as deep as I can go. I can't put those together. Leave me alone. They're not the same. All right, maybe. So let me try this. Okay. See what you guys think about that. Try that one out. Okay.
Okay.
Do this thing on a test. Graded. Calm down.
I don't like this passing on.
Got a safety net. that's right. So let me show you a little, not a trick, but a way that I do to organize this stuff. Because you can identify the like terms, and then you have to put them together. So what goes with this guy?
2A and 7A.
I like it. Cool? All the A stuff can go together. Because if I got 5 A's over there and 3 A's over there, I got 8 A's. I can put those together. What goes with this dude? All right, so see, if you underline with different shapes, now if you don't like that, it's okay, but me, this is what I do. So I don't have to rewrite the one other way to do this is to rewrite the whole thing and just move all the A's together, move all the B's together. And like, if you like doing that, great. Personally, I'm like, that's kind of a waste of time. It's the same problem, I just move stuff around. I'd much rather kind of do this. It's a nice visual. So now I can see, okay, these go with these. So 5A plus 2A, 7A, minus 7A. Good, I got no A's. Aw. And then negative 4B plus 6B, 2B. Or not to be, yeah.
Did you say 2B equals 0 or not?
Is this an equation? I'm glad you brought that up. This is not an equation. So could I get an answer for any variable? No. I can only figure out what a variable is if I have an equation, because then I have two sides to work with, right? So any of these kind of things are called expressions. This is an expression, not an equation. And the only thing I can do with expressions is to simplify them. If there's some multiplication in there, I can do it, like put like terms together, and then I have to stop. I can't solve because I don't know what it's equal to. Yeah.
It's a retarded question. Why is it called an expression?
Why not?
Why not? Okay, I just.
No, it's a good question. Believe it or not, you could think of math, and this might sound evil to a lot of you guys, but you think of math a lot like English because it's sort of, we have our own grammar, we have our own rules for how things go. So what do we call in English an expression would be just this phrase.
Yeah.
Doesn't really go with something, it's just a phrase kind of by itself, an expression. Oh, I've heard that expression before. So this is an expression, a mathematical expression. Doesn't really go with anything, doesn't lead anywhere, just sitting there by itself. Cool. So that's a good question, don't worry. Yeah, that's the kind of question I would ask if I was in this class. I'm like, why the hell do they call it that? How are you guys doing so far? Is that all right? Are y'all cool with the fact that there are no A's, so I can forget about them? I don't have to write 0A, because what's 0 times A? 0. It's not even going to show up. Yes, ma'am.
What if you had like a 1A left over that's changed a little bit? How would you write it? 1A, 2B?
Okay, here's how you would write. So if I had, let me do a little tinier problem. 4A plus 6B minus 3A. Right? Is that cool? So then what do I put this together with? Yeah, and this dude's all by himself. So 4A minus 3A is 1A plus 6B.
So it's kind of like whatever's left over.
Exactly. But you don't like list them with commas or something. I think that's what your question was. How do I list them? They're not separate. They are connected by operations. So they have to still be connected by operations at the end. There it was sort of, I could write, if I wanted to, I could write 0A plus. But then what is 0A?
Nothing.
0.
So will we be wrong if we leave a 1 in front of the A, or do we put?
No, you wouldn't be wrong, but I'm trying to keep you away from that. That's perfectly fine. Because it kind of helps you see the flow a little better. So if you have like 7y minus 6y, that's 1y. But does that 1 have to be there? Because what is 1 times y? Y. Cool.
I'll forget.
Don't worry. Yeah. So if I see those around, I'm not going to take any points off. If between now and math 103 or 110, if you could get away from doing that, you'll be better. Technically that's fine, but we just don't write the 1. So if I just have a y sitting here in space, there's a 1 in front of it, there's a 1 underneath it, and there's a first power on it. So math people were like, no. Just understand it's there. If I don't put it there, understand it's a 1. Cool. How are we doing so far? Okay. So let me just remind you guys, I said this before, but I know we all have very different backgrounds, and some of you are probably really good with this stuff. It's maybe stuff later that we haven't gotten to yet that give you trouble. When that happens, you get ahead in homework, you can stare at the wall, whatever you want to do. It's fun. All right, but you got some homework, you get ahead, I love it. Just get way ahead in homework. What the hell? That's awesome. Then you can focus on your other classes later. If you're already a little bit through chapter 3, that's great. We haven't hit your problem spot yet. So here, try this one here. All right, so what can go with, anybody go with this guy here?
Yes.
2 W's, okay. And then anybody go with him?
No.
Anybody go with him?
Yep.
Nope. And there's no more X's anywhere? No. There's no more Y's anywhere? Cool. So what's negative 6W plus 2W? Negative 4W. And then I just collect all the other single digits, right? Minus 4X. Minus 3Y. So don't leave anybody behind. Right? Make sure they're all still there on the next go. Okay. So, somebody decent with that, semi-decent. You're not going to see a lot of, let me just, I like to do this to you every now and again. Here's a harder problem than you will see in the homework or on a test. I just want to give it to you, see what you think about it. I do that every now and again. See, I might have freaked some of you guys out. I should have just said nothing. It's the same exact idea. Are there any like terms in this thing? Which ones?
6 and 6.
4AX.
I like it. Anybody go with him?
No.
No, there's no more A squares and there's no more just A's. So 6 of these and 4 of these is 10 of these. 11. And then just collect everybody else. Cool. So that's not bad, right? You can imagine. I'm not going to do this to you. But I can make this list long. AX squared, C, D, da, da, da. And here's one reason why that matters is if I had 6AX squared minus 2A squared X plus 4X squared A. Here we go. Now here's the one that you definitely won't see from me, besides right now.
Isn't it unsolvable?
We're not trying to solve it.
Well,
It
like,
might be not possible to further simplify. Yeah.
Yeah, that's what
So I know what you mean, but it can. Why do you think it's not? Does this guy go with this guy? What does this guy have in him right now? He's got an A and a couple X's, right? You see it? Does he also have an A and a couple X's? No, he's got 2 A's. Do you see what I'm saying? So those are not like terms. What about him? What does he got? 2 X's and an A.
Yeah.
What did I do there that was evil? I didn't put it in alphabetical order. Who cares, right?
Yeah.
You guys see though? So what I'm trying to do here is to really focus you on what the definition of like term, what it really means. Does anybody else have 1A and 2 X's? Yes. Therefore, those are like terms. So 6AX squares plus 4AX squares is 10 AX squares. And then this dude is all by himself.
Okay, now I'm confused.
Now, if you had any trouble with what I just did, like I said, this would probably be, I'll make something a little bit harder than this for a bonus problem. We're not going to do anything with multiple variables like this yet, except for right now. But I just want to show you how this basic idea applies. I don't care how much more complicated you make it, it's the same basic idea. You have the same letters and the same amount of each other, the same powers on those letters. And then you can combine. Okay. So, let me throw something at you here, like I often do. We'll start over a little list. Anybody know what you can do with this? Whenever I say that, I always wait for someone to say, I'll tell you what you can do with that, Jeff. Yeah.
Don't you, like,
I like it. And this is one of the best properties because it's the most descriptive, is the distributive property.
kind of like foil.
Not quite foil yet, but foil is like, I'm with you. Foil is like two distributions, yeah. Let me explain why distributive property works, because we should be, as a student right now in this class, if you haven't really seen this too much, you should be upset that you can do anything. Because what does order operations say you must do? And can you do anything in there? So they're like, what the hell can I can't do shit. So I don't blame you for saying that, because that's what order operations says. But remember, what really fundamentally does this kind of thing mean? Go back to what I said earlier. X plus X plus X plus X, right? You guys with me? For anything, what's for A? A plus A plus A plus A. What's for Jeff? Jeff plus Jeff plus Jeff. Right? So what's for this? This plus this plus this. You with me? So I have this equals. Now don't worry, those of you who know distributive property, I'm not going to make you do this work. I'm showing you why the distributive property works. And then we get to apply it directly. So 4 of these. And now I just look for like terms, right? How many like terms do I have with this guy? 4. Yeah, 1, 2, 3. So what's x plus x plus x plus x? 4x. And what's negative 2 minus 2 minus 2 minus 2? You with me? Yes, sir.
Isn't there another way where you just multiply?
Exactly. So like I said, here's why the property works, right? And I said, please, dear God, if you have 50 times this, don't write it 50 times, right? So don't do this. Here's the shortcut. 4 times x, 4x. 4 times negative 2, negative 2. But that's why it works, because you really do have 4 of each of these if you were to write it expanded. You guys with me? Okay, so this is called the distributive property. Here, you guys try this one. Maybe not make it too evil. Just there. Oh, you don't say the answer yet.
Okay.
Is that what you're saying? Okay. Stay with me.
You can get the x, like 4x minus 8, like x equal 2.
Is this an equation?
No.
And the funny thing is, if any of you have ever been taught the equal 0 thing and how to do that, you want to make everything in the universe equal to 0. I don't know what this equals. That's why I can't solve for x. If somebody told me it equals 0, then I could figure out what x makes that true. If somebody told me this equals 7, I could figure out what x makes that true. I have no idea what this equals, so I just leave it like that. Cool. So this guy is waiting for somebody to come along and say, oh yeah, x is 7. Oh, good, then I can throw it in. Okay. So what do you guys get here? Good, 33x minus 22, cool. Right, distributive property. The name is awesome because it's exactly what you do. You distribute this to both of those. Why? Because you wouldn't have that many of each of them if you listed it out. Cool. So, here we go.
We can say x equals 33 on way 2.
No, again, is this an equation? Is this an equation?
No.
Do you see an equal sign? No. So you can't set it equal to something arbitrarily because you don't know what this equals. If x is 1, what does this equal? If x were 1, this would be 33 times 1 minus 20 would be 11. If x is 2, this is 66 minus 22 is 40. But I don't know what the hell x is, so I have no idea what this equals. So I can't get an answer if there is no equal sign. I can't solve for x if there is no equal sign. I just have to leave it like this. Yeah.
So when the problem is longer and you have like a 3x, a 5x, whatever, but you also have some just numbers, like a -4 and a -5, can you simplify it and just like add the numbers together, add
Oh, hell
the
yeah.
x's and
Yeah, that's what we were doing earlier, right?
Oh.
You're right, though. I
Why
don't
couldn't
think
you
I've
just
put
click
just
to me?
pure numbers.
Sorry.
No, you're fine. I just realized I haven't put just numbers by themselves. I've kind of put everybody with a variable, I think, till now, but let me do one with numbers. And those guys are like terms themselves. Anything without a variable,
I
you're
just
like
think
terms.
I finally got it, so I just want to make sure I got it, so I'm not doing my homework wrong.
Oh, it's okay. Don't worry. So let me throw one sort of like what we've done.
I had a good moment, I got it.
Okay. So the instructions would say simplify. Simplify means carry out the operations. Do any multiplication, add your like terms, stuff like that. So just to kind of help us out a little bit, because I'm throwing something kind of new into the mix, your eyes should automatically be drawn to parentheses, which is good. Order operations kind of force us to look at those first. So I should kind of look at this guy first. So now I can do, apply that property. And the reason I want to do that, I want to get my x's together. But aren't some of my x's stuck inside? Do you see that? So if I distribute, I free them. I break them out of there. So now I'm able to get them together with any other x's. So this guy's still here. What's 5 times x? 5x. 5 times -2. So now everybody is free. Now I can put together my like terms. So what goes with him? -10. Like, so 3 minus 10? -7. And what goes with this guy?
6.
Good. 5 plus 6? 11. Careful, it's positive 5, positive 6. Yeah. So it'll be positive 11. How are you guys doing there? Is that? So the one step I've added there is that distribution step before you start putting your like terms together. Yes, ma'am.
Say if the x was by itself, and it was just plus x, would it be like plus 1x?
Exactly. So if you your answer, you could leave it like that. And if you see something just hanging out, you could put a 1 there if you want to. Math doesn't have a problem with that. Teachers really shouldn't have a major problem with that, but it's just convention not to put the 1 there at the end. But you could put a 1 anywhere you want to where there's a variable sitting by itself. And when we get to, well, I don't think we'll get there in this class. When you get to factoring in the next class, putting that 1 in places will make a lot of factoring methods a lot easier. Putting that 1 in there, you're like, oh, I see it now. I can see what to do. Yeah. Okay. I'll give you one more. Here we go. Let's see what you guys think about this.